Good evening. Welcome to the video forecast discussion for February 12th, 2014. It's currently 12:50 p.m. and I'm your meteorologist Stephen DiMartino, and we have a winter storm on the way. This winter storm will be a long duration winter storm, something that we haven't seen over much of this winter. Much of this winter we've seen 6-hour snowfalls. They're intense. They come through, they leave. This storm is different. It's a long duration storm with a lot of different phases. I'm going to break down these phases and I'm going to explain how I get to this forecast and how some of this forecast might have to change during the duration of this storm. I'm going to be following this storm from start to finish, so you can be sure you can follow the latest weather information at nynjpaweather.com and nynjpaweather at Twitter, Facebook, Google+, but mostly Twitter. And also follow NYNJPAWX as a backup. So now we got that out of the way, let's take a look at the observations and why I'm concerned and why the models have trended colder in specific locations in the atmosphere. Very key point. You can't just say it's colder overall. It's not. But there's a lot of interesting data coming out here. First of all, here's our observations. And if you don't know, it is cold out. Temperatures are in the mid to upper teens over the interior, upper teens to lower 20s over the New York City metropolitan area, lower to mid 20s over southern New Jersey and the Philadelphia metropolitan area. Notice the winds are relatively light and they're from the north and the northeast. Now, these surface winds are going to be huge with this upcoming storm because we have Arctic air locked in over New England. And that source region is going to be drained south along the coast. In fact, it is right now with a major ice storm going on over the southeast. The high pressure system is departing. There's no debate about that. However, the track of this storm is going to be incredibly important for locations just away from the coast in terms of this wind direction and just how fast, if at all, this cold air erodes at the surface. Here we have the radar, and yeah, this is pretty moisture loaded, and this disturbance hasn't even really got its act together yet. We have a ton of moisture being pulled not only from the Gulf of Mexico, but also from the tropical Pacific, which I'll show in the water vapor, and also we're starting to get it from the Atlantic. We have snow and ice over the southeast. It's a disaster over Georgia with heavy freezing rain, and it's going to take a while to get over this storm over portions of the southeast. And this storm and this moisture is slowly going to inch its way northward towards the Philadelphia and New York City metropolitan area tonight by about 11 p.m. And when it does, it's going to fall initially as snow for everybody. Now, this is interesting. This is an Arctic front. This disturbance is important because it allows this disturbance to tilt in a negative axis with the trough, and that is going to be a huge factor for the storm at the end. So the fact that this is pretty close is pretty important. Not going to be a full phase, but it's going to have interaction on this trough. Now on the infrared satellite picture, I want you to keep an eye on this. You see all these yellows and oranges here? That means we have intense lifting here. Again, this is before the storm even gets its act together. So what do we really take from this? What this is telling me is that we have an intense thermal gradient along the southeast coast, and you can extend it all the way up through the mid-Atlantic. And you have intense lifting as a result of the interaction between the Arctic air and the tropical air. And you have that boundary right here. Now you have a low pressure system starting to get its act together around the Gulf of Mexico. You have high pressure locked in here. That is going to slowly slide to the east. What you have here set up is a cold, stubborn Arctic air mass. I want to repeat that again. Stubborn Arctic air mass with a snowpack in place outside. And if you don't believe it, there's about an inch of ice on my driveway that I'm still trying to get off. It's a pain in the neck. This is important because what it does is that it enhances the staying power of the cold air at the lowest levels of the atmosphere. 850 millibars warms up just fine. There's nothing to prevent it. There's no influences, no friction on the air mass itself. But when you got 8 inches, 6 inches, even 4 inches of snow and ice on the ground with an Arctic air mass, those Arctic air masses don't tend to leave as quickly as what the models try to show. So what you have to do in this type of situation is that you don't just go with one model. That's kind of a novice kind of way of going about this. You have to use models for what they're meant to be used for. They're tools. They're not crystal balls. So for example, if I want to get a better idea of the lower levels of the atmosphere, I use the NAM model guidance. If I want to get a better idea of the overall structure of the mid and upper levels of the atmosphere, I use a global model like the Canadian model, the European model. And then you combine them and you work them out. You take pieces of it and say, okay, what makes sense? Why is the model doing what it's doing? And would it make sense in the overall scheme of the pattern that we have in place now? That is how you forecast. You don't just take one model and say, well, we're going to do this model. You take all the models and you take pieces of them and you utilize the best parts of that model as far as the best capabilities that they have. For example, you don't use the GFS long range model guidance for a mesoscale thunderstorm event. Okay? That's when you use the small scale models, the NAM model guidance, the RAP model guidance, the HRRR model guidance. Yes, it's literally HRRR. Sounds like a pirate. So my point here is that you can't just use one model. You have to kind of piece everything together and see how the whole storm evolves here. And what this is telling me here, and we're getting new data right as we speak, is that we're getting intense lifting here. So we have a very dynamic system with a very strong thermal gradient, not only at the vertical, but at the horizontal levels of the atmosphere. Remember, because the atmosphere is a three-dimensional or four-dimensional really aspect with several chaotic factors involved. Now that we got that out of the way, let's take a look at the water vapor, my favorite tool. Now look at this. Look at all this lifting. Now look at the connection here that we have. We still have a slight connection here with the Pacific. Very impressive. Then we got the Gulf of Mexico. And now we're starting to get that pull in from the Atlantic. You see that nice expansion going on here. This disturbance is key. Here it comes. It's diving south. It's going to phase with this disturbance and just cause this storm to blow up to the east of the Mid-Atlantic coast. East of the Mid-Atlantic coast. Remember, the model guides had this low pressure system practically going on New Jersey, which of course would be driving rainstorm. Now the low pressure system is tracking to the east. Now I'm showing this in the model guidance using the latest Canadian model guidance to show the point here. You use the Canadian model guidance and you combine that with the mesoscale model guidance, you see you have a sustained north-northeasterly wind based on the guidance, which would make sense on the storm track at the coastal plain. And remember, in Albany, just to go back here, it is 15 degrees with a dew point of -3. Saranac Lake, 13 degrees. New England, 9 and 10. And it's 1 o'clock in the afternoon. Kind of get my point? We have a lot of Arctic air to work with here. So when I'm looking at the water vapor satellite picture, I see plenty of moisture. This trough here that I've been keeping an eye on to see, gee, I wonder if this will kick this a little bit further east than what the guidance has been showing. Well, look what it did. It shifted just enough southwest to allow this storm to blow up, but it is pushing everything slightly east. That's why we saw this slight east trend, a little bit of a correction. So we know what this is doing. It enhances the pattern. That's all set in stone. We have this storm developing. We have this high pressure system. Now, the Atlantic pattern isn't optimal for a setup here to keep that high pressure system locked in. But this high pressure system that's dropping south is key because it's going to help to keep that cold air a little bit more sustained than what the global model guidance is starting to show. Go look at the regional analysis again. Here's our high pressure system over New Jersey. That is exiting. If this was not exiting, this would be a major, major snowstorm for the coastal plain, for everybody in the coastal plain, from Cape May to New York City to Boston. But it's leaving. So that means we're going to definitely mix over. This high pressure system is what I'm talking about to watch out for. And here's our cold front. Now let's go look at the model guidance here. This is the Canadian model guidance. Now look what happens here with this low pressure system. Tracks up towards the Delmarva. It explodes tomorrow afternoon down to 994 millibars just to the east of the Delmarva. And now look what it does. Look at that track that it does. Okay? Moves in this direction. We'll do that again. Here we are at the afternoon. Here we are in the evening. Afternoon, evening. And it's down to, what is that, 896 millibars? So this storm rapidly explodes. Impressive. Now, why is this important? Why is this track important? Because while the mid-levels clearly warm up here, because of the track of the 850 millibar low, I think the lower levels of the atmosphere remain cold. And I think that right around the I-95 corridor, that freezing line is going to be awfully close, and it's not going to budge very quickly, especially with a snowpack in place. And so that is why I've been advertising a lot more ice than what a lot of other people have been suggesting. I've seen this before, and quite frankly, I'd rather be safe than sorry, because this track, we'll do it again, there, leads to a north-northeasterly wind, not an easterly wind. If this was, let's say, tracking up towards Long Island, easterly wind, no problem. But this track that goes in this direction is a northeasterly wind. And that northeasterly wind is being pulled in from New England. See my point? So even at 850 millibars on the Canadian model guidance, here's the freezing line at 850 millibars. It basically gets up to about the I-95 corridor and then stops. So basically, it gets through portions of eastern Connecticut, gets through eastern Long Island, but then it bisects western Long Island just to the south of New York City, cuts right through central New Jersey, and then stays, I'm going to repeat this, stays to the south and east of Philadelphia. Yeah, it's going to get interesting, ladies and gentlemen. It's going to be very interesting with this storm. So it's going to be a very fine line between those who get all snow, those who get snow, sleet, and freezing rain, and some significant icing, and then those who go over to plain rain. I think the New Jersey coast immediately, like Belmar, Atlantic City, those locations rain. You're going to be dealing with, unfortunately, in this situation, coastal flooding. You're going to be dealing with urban flooding because of the heavy rain. And you're going to be dealing with coastal flooding and wind concerns because you're going to be dealing with a 20 to 30 mile per hour wind with wind gusts over 40 miles per hour with this type of storm. But I do think you dodge the first bullet. As I said, first bullet. Now let's go look at 1 a.m. on Friday. You might be noticing this. This feature is showing up all over the place on all the models this morning. What happens is that the atmosphere starts to stretch because the trough goes negative. You have very cold air coming in aloft at 850 millibars as opposed to the surface. The surface is right around freezing, but 850 millibars drops down to minus 6 degrees Celsius. And so what happens on late tomorrow night into early Friday morning is that you set up a very convective environment, a very unstable environment, and the potential for what looks like to be a deformation zone on some of the model guides here that sets up and drives through the Philadelphia and New York City metropolitan area. And ladies and gentlemen, this is all snow here. So this is going to get very interesting late Thursday night into Friday morning with the potential for very heavy snow, which is why I increased the snowfall totals in the forecast. There's a lot of volatility here. We're really going to have to watch this storm evolve. But there's a lot of signs here that suggest this is going to be a very impressive storm, and it's not going to be as easily handled as some might suggest. So here's the forecast again, looking at 11 p.m. Wednesday through 2 a.m. Thursday, end time 2 to 5 a.m. Friday. Watching a deformation zone, going to be an issue. Worst conditions, 5 a.m. Thursday through 1 a.m. Friday. Might extend this to 3 a.m. Friday if that zone really sets up and rocks out. Now again, for the forecast, in zone 1, dark green, trace to 2 inches. This is not a big deal for you for southeastern Long Island and for Cape May, New Jersey and Wildwood, no big deal. Zone 2, you'll hold on to the snow a little bit longer, maybe a little bit of sleet as well. 2 to 4 inches of snow. That 4-inch amount will be close. It will be further north and west as you get away from the coast or towards central Long Island. Zone 3. This is my volatility section. This is where I'm looking at 5 to 10 inches of snow. The closer you get to the coast, the more likely you see 5. Ice potential of 1/10 to 1/4 of an inch. Remember, that ice potential, I would say, would really be focused over central Connecticut, back down through New York City, over central and western Monmouth County, Mercer County, Middlesex County of New Jersey, back towards southwestern New Jersey, and the Philadelphia metro. Right in this section here. High volatility here. I could easily make a case on some model guides of some of these locations around Philadelphia, New York City, right around Newark, staying all snow. It's going to be that close. Okay, so looking at 5 to 10 inches of snow, someone could actually end up with a foot here if this deformation zone really sets up. I've been in these situations before with this type of zone here, and they could surprise a lot of people in a big way. So we really have to watch out and see how this evolves. Hopefully it's not as intense as some of the mesoscale modeling is showing right now. And then in zone 4, this is almost all snow. Maybe a little bit of sleet mixed in with some warm pockets at the mid levels of the atmosphere to about 975 or 925 millibars. So what you'll get is that you'll get this heavy snow, and it'll back off in intensity, mix in with a little bit of sleet, and it'll back over to heavy snow once the lifting intensifies again. Looking at 10 to 14 inches of snow overall. Someone's going to be around 18 inches. I would not be surprised if someone pushes at 2 feet. Wouldn't be surprised whatsoever. But for right now, because of the way that the storm is evolving, I'm stopping at 18 inches. But at this point, 18, 24, it's a lot of snow. Be prepared. And this is a heavy, wet snow. So there's going to be a high threat for power outages. And please use caution shoveling this snow. It's going to be like cement. Trust me, you want to go to the gym for the next couple of days after shoveling this stuff. So Lancaster, York, Reading, Allentown, Scranton. I know some of you guys up there in Scranton have been begging for snow. Well, you're going to get it with this storm. And also over much of western Connecticut. Again, if you're right along the edge of this line here, if you're just southwest of this line, Philadelphia, over central New Jersey, New York City, any slight shift to the east, and you start getting into these areas here, that's why I bumped up this snowfall total. You got that deformation zone, and then you get a little bit of shift to the east. We're dealing with more snow than ice then. So this is a very complicated storm, and one that we're really going to watch out for in the pink zone 3 area. And of course, throughout this storm, there's going to be a threat up until about Thursday afternoon for coastal flooding with that northeasterly wind and northeasterly wind driving water into the coastline, especially around the Battery and coastal New Jersey. With that being said, by the time we get to Thursday night into Friday morning, winds shift to the northwest. Watch out for portions of the inner bays in New Jersey and also around Long Island with that shift, and portions of northern Long Island with the Long Island Sound here. Then it clears out, and then we have some light snow on Saturday morning. Not bad. Maybe 1 to 3 inches of snow. Isolated 4th inch around southern New Jersey. And then we warm up, and we end our winter pattern. So this is it. This is the big storm. We're going to be having live coverage from this afternoon all the way through Friday. I got my Red Bull, I got my Spike, I got caffeine and everything, I got coffee here. So we're going to rock this out in a big way. Follow the storm all the way through. Looking to do updates on the top of the hour, every hour on Twitter. That way we don't get into Twitter jail. And of course, we'll have premium live coverage for all you premium members out there as well. So I'm your meteorologist, Stephen DiMartino. Get ready for this storm. It's going to be pretty interesting out there, especially if you're just away from the coast. As always, stay safe out there.